This video is the first example of an instance where you are given a problem where you need to come up with the equation of a line and use that equation to answer various questions about the problem situation.
So in the first example we're going to do together for using linear models is this here. Your textbook walks you through the process a whole lot as you get to some maybe perhaps more uh, challenging math courses, should you need to take them. Some of the steps would be taken out and leaving it up to you to recognize you have to do it. But here it says retirement plans. Based on the retirement plan available by his employer, Kai shows that if he retires after 20 years, his monthly income will be $3,150. If he retires after 30 years, his monthly income increases to $3,600. Let X represent the number of years of service and Y represent the monthly retirement income. And you're asked to do these several things with it. Interpret the meaning of the point 30, comma 3600. Plot the ordered pairs 20, 3150 and 30, 3600 in a rectangular coordinate system and graph the line through the points. Find the linear equation and slope-intercept formula that relates the monthly income to the number of service years X. Use the equation found in Part C to find the monthly income for 15 years of service, and E to interpret the slope. So there's a lot of things that they're having to do here, and a lot of times, the graph is nice to have in order to see if everything seems to be in order based off of what you're coming up with, algebraically versus what would be seen in a graph. It's nice, but it's not necessary. Basically, in this question here, if I wanted to figure out, the main question that would usually be posed to you would be something like in D, to figure out the monthly income if Kai were to retire after 15 years, as compared to these two lengths of time that are in here. So and knowing what this slope means is also part of doing that as well. So but let's just go through what they're asking us to do. So it says interpret the meaning of point 30 comma 3600 in context to this problem. Well, as you can see, that corresponds to the situation where it says if he retires after 30 years, his monthly income increases to 3,600. Well, that's what that represents. It basically says that after 30 years of service, his monthly income will be $3,600. So that's all it basically means. And as far as part B goes, now one of the difficult parts might be for you to set up a graph that would fit these because, obviously you're not going to move by ones on a typical piece of graph paper because you wouldn't get up to 3,150 or 3,600. You might even have difficulty getting up to 20 or 30. So I scaled a graph and drew it according to this. And you can actually even just almost do a sketch too, as long as you're showing that the two coordinates are these here, and you're good. But having the more accurate the graph, though, as you do other things subsequently, I could kind of do a very basic check of my equation as I go through this, based off of what I see the y-intercept, and if they seem to agree with each other, that might mean I'm on the right track, and so forth. So, but that's what the graph looks like right now. So part B is done. Part C, find the linear equation and slope-intercept form that relates the monthly income y to the number of service years X. So I calculated the slope as we had been doing in the previous examples from this lesson. And so I get a slope of 45, and I'll talk about what that 45 means momentarily. And I set up y equals 45x plus b, and I'm going to make use of the point 30 comma 3600. I could have also chosen to make use of 20 comma 3150, as long as I'm using the both parts of the ordered pair and not like the x coordinate of one with the y coordinate of the other ordered pair. That's sometimes what happens with some students, and it causes them to come nowhere close to the right answer. So with that in mind, I know that 3600 would be 45 times 30 plus b. B would be 1,000. B plus 1,350 equals 3,600, which means B would equal 2,250. So the equation of the line is y equals 45x plus 2,250. And so basically, I could put that in my graph now too. There you go. And you can kind of see here that this is saying that the y-intercept's at 2,250. Now I can see on the graph here as I go up, each one of these lines here, these horizontal lines are 100. So when I look at here, that's 2,100, 2,200. So the y-intercept is definitely a little bit over that, but doesn't quite get to 2,300. So that seems to be a very reasonable location for the y-intercept based off of what we have, from the equation, but also what we had originally from the graph that was drawn between those 2 points. So moving on to the next part, now we're asked to make a prediction, basically. Use the equation to find the monthly income for 15 years of service. So here I'm going to let x equals 15. And of course, monthly income is going to be the y value. So I'm going to use this equation right here. And I'm going to substitute 15 into it, and I'm going to calculate it out to get 2,925. So based off of that, if Kai retires after 15 years of service, his monthly income will be $2,925 per month. And again, I mean, the graph helps us do some checking of that if we want to, because I can see now, based on this, 15 comma 2,925 should be a point on the line. So if I try to plot where that is, roughly, 15's right there. Come up to the line and then kind of fall over this way. Is that about 2,925? I mean, I can't say for certain because the graph scaling doesn't allow me to do that more accurately, but it seems reasonable. So it's another way of kind of verifying that it seems to be on the right track, because our graph and what we're calculating algebraically seem to be agreeing with each other. And so lastly, interpret the slope. So basically, I have to kind of know what this means, and coming back to where the slope is, this is essentially monthly income over years of service. So basically, what I'm going to be getting here for the slope, or 45, that means, since it's positive, it's a $45 increase per month for each year of service, and that's how you'd interpret it. The slope of 45 represents the fact that Kai's monthly income would increase by $45 for each additional year of service. And that's the end of this question.
So that is the end of this first example. Please make sure to go on to the next video where we will review a second example where we need to write the equation of a line in order to solve and answer various questions about a problem situation.